The idea of instantly draining Earth's oceans and terraforming Mars with that water is not just the greatest construction project in history, it is a physical death sentence for both planets. We are moving 1.35 billion cubic kilometers of water, approximately 1.4 times 10 to the 21st power kilograms, across the vacuum of space. Here is the breakdown of what would happen from the perspective of physics, geology, and astronomy. 1. Earth, the mask, falls off. As soon as the water vanishes, Earth ceases to be the blue marble. Geological collapse. The weight of the oceans currently presses down on the oceanic crust. Removing this massive load would trigger an isostatic rebound. The ocean floors would suddenly spring upward, causing global earthquakes of magnitude 10 plus as tectonic plates violently readjust. Atmospheric death. Oceans absorb massive amounts of CO2 and produce 50 to 80% of our oxygen via phytoplankton. Without water, the planet's heat capacity plummets. Earth would bake during the day and flash freeze at night. Soon, the atmosphere would become unbreathable due to a surplus of carbon dioxide that can no longer dissolve in water. The view. You would see giant mountain ranges, mid-ocean ridges, and the deepest trenches, but it would be a lifeless salt desert, littered with the hulks of sunken ships and the skeletons of marine giants. 2. Mars, the birth of the great ocean. Mars has only 38% of Earth's gravity. When we pour Earth's water there, the planet's geography changes beyond recognition. The Northern Plains Ocean. Due to the north-south dichotomy of Martian terrain, almost all the water would flow into the northern hemisphere. A giant ocean several kilometers deep would form, covering about a third of the planet. The southern hemisphere would remain a massive mountainous highland, a Martian supercontinent. Boiling and pressure. Here lies the main problem. Atmospheric pressure on Mars is less than 1% of Earth's. At such low pressure, water boils even at low temperatures. Mars would immediately be shrouded in a thick, suffocating layer of water vapor. 3. The physical paradox. Why Mars can't keep it. Even if we filled Mars with water, the joy would be short-lived. Atmospheric loss. Mars lacks a global magnetic field. Solar winds would relentlessly bombard the water molecules in the upper atmosphere, stripping away hydrogen. Over time, your new ocean would literally leak into deep space. The Big Freeze. Mars is much farther from the Sun than Earth. Without a massive greenhouse effect which the water vapor might initially provide, the new ocean would quickly turn into an ice sheet hundreds of meters thick. Mars would become a giant snowball. 4. Orbital consequences. Moving such a significant mass, even if it's only 0.02% of Earth's total mass, affects the dynamics of the system. Earth's rotation. Changing the mass distribution would cause Earth to rotate slightly faster. The figure skater effect, pulling arms in. The length of a day would shorten by fractions of a second. The solar system balance. Mars would become slightly heavier, which could subtly alter its orbital path and its gravitational relationship with the asteroid belt over millions of years. The 1,000-year outlook Earth becomes a scorched, rocky wasteland with a toxic atmosphere. Mars becomes a planet covered in endless ice shields that are slowly evaporating into the void. Transferring the water doesn't save one planet, it ruins both. Unless we find a way to give Mars an artificial magnetic field and a much denser atmosphere first.